We can verify inverses. You can determine whether two functions are inverses by finding both of their compositions. If both compositions equal the identity function, I of x equals x, then the functions are inverse functions. So what that means is that if you have two functions, and let's call them f of x and g of x, they're going to be inverses if f of g of x equals x and g of f of x equals x. So if we do a composition of functions by plugging one of the functions into the other one, and we do it both ways, we do both f of g and g of f, and they both come to simplified to just x, that means that those two functions are truly inverses of each other. So, determine whether each pair of functions are inverses and explain your reasoning. Your explanation is simply just showing your work. So, on your assignments, you would have to show your work on these. So, if f of x equals 3x plus 9 and g of x equals 1/3 x plus 3, then we can start by seeing if these are inverses by doing f of g of x. And what that means is that we're going to take the g function and plug it into the f function. So starting with 3x plus 9, we will replace the x with the g function, and the g function is 1/3 x minus 3. So I replace the x with 1/3 x minus 3, grouped it in parentheses, plus 9. And then we simplify, so we do a distributive property. So 3 times 1/3 x is just 1x, or x. 3 times -3 is -9, and then plus 9, that's hanging on the outside of the parentheses. And x minus 9 plus 9 equals just x. So we have shown that f of g does equal just x. But that's not good enough, because we should also show that g of f equals x as well, because it is possible that it works one way but not the other way. So that means we'll start with the g function, which is 1/3 x minus 3, and then replace the x in the g function with the f function, and the f function is 3x plus 9. And then we simplify. So we do 1/3 times 3x. So that's 1/3 times 3 is just 1. So that would be 1x. And then 1/3 times 9 is 3. And I did forget to bring down this minus 3 hanging on the outside there, so I'll bring it down now. And x plus 3 minus 3 is just x. So you can see that we also get x on g of f. So since we get f of g is x, and g of f is x, that means that, yes, these are inverses. Part B, do f of x equals 4x squared and g of x equals 2 squared of x. So we're going to do f of g of x. So we're going to plug the g function into the f function. So we'll start with the f function, 4x squared. And then replace the x with the g function, which is 2 square root of x squared. So we do have to do our exponents first. So there we have 4 times, and then what is 2 squared of x squared? This is not a distributive property or a double distribute. We're not going to have to do 2 times 2, 2 times square root of x, or anything like that. It's just going to be 2 square root of x, because there's no plus or minus in there. So 2 squared is 4, and the square root of x squared is just x. So 2 square root of x squared is 4x. And then 4 times 4x is 16x. And that's simplified, and it did not come up to be just x. It came up to be 16x. So that means we already know the answer to this. Since we didn't get just x, that no, these are not inverses. And there's no reason to do g of f of x, because we already know the answer. G of f of x might work, but it doesn't matter, because f of g did not work. Let's do one more. So this time is 2x squared minus 1, and g of x is the square root of x plus 1 squared. So let's do f of g of x first. So starting with the 2x squared minus 1 function, replace the x with the g function, which is that whole square root, So that'll be the square root of x plus 1 over 2, and then squared minus 1. And when you have a square root and it's being squared, those actually just cancel each other out, so that's pretty handy. So we get 2 times x plus 1 over 2 minus 1. We have 2 times that fraction, so we have 2 times x plus 1, and then you turn right back around and divide that by 2. That means the 2's cancel, leaving us with just x plus 1, and then minus 1. And plus 1 and minus 1 means that those cancel, so we're left with just x. So far so good. We might have a couple of inverses here. But we still got to find g of f of x. So starting with the g function, and that is x plus 1 over 2. Now replace the x in the g function with the f function, which is 2x squared minus 1, and then that plus 1 over 2. And on this one, I see that what I should start out with is I've got 2x squared minus 1 and then plus 1. So minus 1 and plus 1 will cancel each other out, leaving us just with 2x squared over 2, and still underneath the square root sign. Well, you have a 2 on the top and the 2 on the bottom, so those cancel, leaving you with just x squared, square root of x squared, and the square root of x squared, the square root and the squared cancels. So that just leaves us with just x. So that also simplified to x. So since both of them simplified to x, then we could say, yes, they are inverses.